a couple of things. Okay, so we have a demand equation. X is the price we charge. The demand is 100 minus 2x. So if x is 0, that means there's a demand for 100 of these things. Okay? So demand is 100. Here's the point. 0, 100. That makes sense? If x is 0, demand is 100. Okay? And we could say y equals demand, but I don't want to do that. Okay? And as we said, you know, example, if x is 10, then 2x is 20. 100 minus 20 is 80. So only 80 people want it if x is 10. So we could come out here where x is 10 and plot the point 10, 80. We're not going to do that. We're just going to plot the whole graph. Okay? Now, this is a linear function. It's like an mx plus b, right? And what's m? Negative 2. So what's it? It's what you multiply by x, which would be negative 2. And b is 100. Okay? Now this is all stuff that I kind of assume you've seen. So I'm going over it fairly quickly. Okay. Now the question is, what would x have to be to make the demand 0, right? Now you can pretty much just look at it and say, well, x has to be 50 because then 100 minus 100 gives you 0. But you don't, you know, you can't always just look at it. So how do we get? Okay, this is your like your y-intercept or your vertical intercept occurs when your horizontal coordinate is 0. Horizontal coordinate's x. If x is 0, the vertical coordinate's got to be 100, right? Everybody understands that? And you should, in terms of what we've done. Okay? So, we can think x-intercept occurs when y equals 0, right? We think of this as y. So when is the demand 0? Well, (100 minus 2x is 0 if x equals 50. You can solve that equation easily. Okay? So we come out here and we put 50 right here, and then this is a straight line because you have a constant slope. Okay, so there's a graph of our demand. Now the range of the demand function, why can't the graph continue to the left of the vertical axis, or can it? What would it mean to have a point to the left of the vertical axis?
Paying people to take it.
I'm sorry, a little louder?
You'd be paying people to take it.
Yeah, you're paying people to take it. You're charging a negative amount, right? It doesn't make any sense to charge a negative amount. Okay? I'll charge you negative $50 for this, meaning I'll give you $50 to take it. And I probably have things I'd give you $50 to take away, but you know, that's not how we do business. Okay? It doesn't work for this model. Okay? And why aren't there points that go beyond here?
Because then they'd be giving them to you for
Yeah,
money?
you'd have a negative demand. Now maybe there could be situations where, you know, you have things that are in flux, and maybe, you know, other people have these and they would give them to me if I charged enough, which doesn't make sense. Okay? So I don't know that we can make sense out of that one, but you want to think about those things. That's
That'd be
interpretation.
like money trading, though, right?
Huh?
That'd kind of be like trading money.
Yeah, and don't get me off in economics because I don't know much. But anyhow, you have this, I know the mathematics, I just don't know the terminology, it's weird. Somebody in math and physics, economics is a weird sounding science. Things are counterintuitive to the physical intuition. But they make perfect sense to accountants and financial people. So that's fine. Apparently I've only got a one-track brain or something. Okay. So we've got this. Now, we also have, okay, well, if your demand is 100 minus 2x, then if you sell, your demand is how many you sell. So how much money are you going to make if you sell X of these? Now, it might not be how much we actually sell, but it's what we expect to sell. Okay? And then how much money do we expect to get? Well, if I sell it for $10, how many am I going to sell?
80.
I'm going to sell 80, right? X is how much I sell it for. We plug that in and we see what the demand is, and that's how many we expect to sell. That's our predicted demand. Might not be the actual demand, but that's our model. So if I charge $10, I sell 80. So make sense? If I sell 80, how much money am I going to take in?
$800.
Yeah, multiply how much I charge by how many I expect to sell, right? And that's our revenue. $80 times $10 or $800. Okay? Now, is that our profit? Why not?
Manufacturing cost?
Huh?
Manufacturing cost?
Yeah, maybe I make these in my spare time and I don't pay myself anything for my time. So maybe that is profit if I don't count my time. But typically in a business, somebody who sells something doesn't manufacture it. So you got to pay the manufacturer, right? And of course, often, the more you buy, the less it costs per unit, right? And why is that? Well, it goes something like this. Okay? I'll say if there's a cost to me, then profit's going to be less than revenue, badly written. Okay? If profit, why is profit less than revenue? Profit's revenue minus cost. And cost generally depends on how many I expect to sell, because that's how many I'm going to tend to buy, right? Now, in reality, it's a little more complicated than this. It's an oversimplified model. These things aren't necessarily linear, but a lot of times they're pretty close to linear, okay? And there are other issues. I'm probably going to buy a little more than I expect to sell, and then it gets complicated trying to decide just how many I want to buy to be sure if the demand is a little higher than I think it will be, that I can accommodate it and, you know, not make people mad, right? Because everybody wants these things badly. Okay, yeah, I've got to take all that into account, and this model doesn't go that far. It just says, okay, I'm going to assume that I'm going to need X of these, or I'm going to need, you know, the number I need is going to be the demand, and that's how many I'm going to buy. It's not quite realistic, but that's the starting point for the model. So, let's assume the cost is of each thing is $10. Oh, so they'll say $100 plus 0.5x. This is because whoever manufactures these things needs $100 to get set up. And then they can run them for 50 cents a piece. Okay? Actually, I saw they run them for $5 a piece. So, profit is revenue minus cost. Revenue is, well, we haven't figured out what revenue is for X of these. We could figure out what the revenue is if I charge $10. I mean, I know what the revenue is if I charge $10. And if I charge $10, how much is it going to cost me to make these? Or to buy them? If I charge $10, they're going to make 80, right? So X is going to be 80. That's how many I'm going to buy. I buy 80 of these, and 5 times 80 is, put a dollar sign in front of that, $400. Add that to the $100 of upfront cost, and it's going to cost me $500 to get these made. Then I sell 80 of them, I make $800. I take in $800. My profit is going to be what? $300, right? Okay? Because I'm going to get $800 by selling them. I'm going to need 80 of them. It's going to cost me $500 for those 80. I'm going to clear $300. Okay? Okay, so profit is revenue minus cost equals what? Well, we haven't finished seeing what the revenue function is. We only know the revenue if I sell 10, right? So, we can work this out. If the price is X, I'm going to use the word demand. The demand is 100 minus 2x. So we sell 100 minus 2x of the thing at price X. Well, if I sell this many at this price, how do I get my revenue? If I know how many I sell and how much I sell it for, what do I do with those numbers?
100 plus 5y.
I'm asking for just some words. If I know how many I sell, And the price I'm charging, what do I do with those two quantities?
Multiply.
I multiply them to get my revenue, right? Now, I think you answered the ultimate question, but we wanted to get through the intermediate question. Okay? Get it in our heads that if we know how many we're selling and how much we're selling them for, we can figure out how much we're going to get by multiplying those two numbers, right? So we sell this many at this price. Thus, the revenue equals number sold times price. Number sold is the demand. You know, that's the equivalent to saying number sold, because we're assuming we're going to sell the demand, right? Whatever demand is, that's how many we expect to sell. That's what demand means. And that equals 100 minus 2x multiplied by x. That's negative 2x squared plus 100x. I'm losing my voice or something. Negative 2x squared plus 100x, right? That's revenue. Now, the cost is this. Profit is revenue minus cost. Now we've got an expression for the revenue, we've got an expression for the cost. That's negative 2x squared plus 100x minus the cost, which is 100 plus 5x. I'm leaving off the dollar signs. Okay? Because units get a little complicated here. And you can check this out. That's 2x squared plus 95x minus 100. So there's our profit function. What kind of a function is this? It's a quadratic function. What kind of a function is this? Linear. What kind of a function is this?
Linear.
Uh-huh. And what kind of function is x? Really simple linear function, okay? So I multiply a linear function by a linear function and I get, well, that's already a quadratic function, isn't it? And then I subtract a linear function from the quadratic function. Well, if I add or subtract a linear function to a quadratic function, it's still going to be quadratic, okay? So I have a quadratic function, and what do I know how to do with quadratic functions? Sorry?
Graph it.
You can graph it. What could you determine from a good graph? It might be relevant to your business.
Axis of symmetry, 0.
I'm sorry?
Axis of symmetry.
Okay, well, when you graph a quadratic function, you get the zeros and axis of symmetry. It's a good place to start, right? Then maybe you graph it by transformations. Okay? And, okay, what's the graph of this function going to look like? Is the axis of symmetry going to be to the right of the x-axis or the left?
To the right.
It's going to be to the right because you're going to need negative b over 2a. b is 95, a is 2. It's going to be negative 95 over 2 times negative 2, right? The negative b over 2a. And that's going to be 95 fourths, okay? Which is what, 24 and 3/4, about 25, okay? So the axis of symmetry for this function will be around x equals 25. Now, Once you've got the axis of symmetry, what do?
Find the vertex.
You find the vertex. And what's a vertex going to be like? You've got a negative in front of x squared, right? That means if you start with the x squared graph, you're going to multiply x squared by -2. It's going to give you a vertical shift. It's going to reverse things underneath the axis, and then you're just going to go horizontally and vertically to get to the vertex, right? Now that's a process that some of you have mastered and some of you are still having trouble with, but we've got to nail that, especially for quadratic functions. Okay? Okay, then what's your vertex going to tell you about the whole business situation here? Well, what does the vertical coordinate of the graph of profit versus cost or versus price look like? I mean, what's the vertical coordinate mean?
Show you the best price to sell them
I'm sorry, Daniel.
for. The best price to get the most profit.
It's a little simpler than that. You're graphing profit versus your price, right? So you graph profit versus price. What goes on the vertical axis? Well, you know it's not going to be x, don't you?
Profit.
Profit goes in the vertical axis. Okay? And the graph is an upside down parabola. So what's that vertex tell you about profit?
The maximum profit.
Yeah. It's where the profit peaks. Is that handy to know? Well, you see, one of the big things that you use mathematics for is to optimize things. This is a very simple example of how you optimize. Now, if this is a cubic equation, you wouldn't know how to optimize it. Okay? If it's a quadratic equation, so you certainly do. You just graph it and find the vertex. If the vertex is at the top, which it will be if the coefficient of your x squared is negative, that means you've maximized. That's the maximum you can have, whatever it is you're doing. Okay? If it's an upside down parabola, then it's a minimum. Like the flow thing. Okay, graph of flow versus time, or graph of depth versus time. The vertex tells you the minimum depth, doesn't it? At least according to the model. Model's not 100% accurate, but it's pretty close. It's more accurate probably than this model would be for an actual business. But this model gives you a framework to tweak things. Okay? And there are numerous examples, and I'm not going to try to think of any right now. But, you know, they come up in the homework, okay? You know, last time we talked about tossing this piece of chalk into that trash can over there. Pathetic. I should be able to do better than that. Ha! Okay. Once I got calibrated, I got lucky. Okay. Yeah, I think I missed dead center by centimeter or so. Dead center isn't really the best place to hit it. Anyway, it just looks good. You don't have to worry about that. We could analyze that with quadratic functions, but you probably need to use a little calculus. Okay? To optimize most functions, you need to use some calculus. Or you need to have a really good graph. If you can construct a good graph, you can get an idea how things optimize. Okay? So I'm not going to construct that graph for you, but you got a homework problem that many of you haven't yet handed in. It kind of asks you to do that, right? And of course, if you don't hand a homework problem in, it doesn't mean that you're done with it, does it? You know, I kind of expect you to go back and work it. Of course, you got a life and everything. But that's the way you learn the stuff that you got to learn. Okay, does that whole thing make at least a little bit of sense? should. If you work the problem, it'll make more sense. Get your hands on it, work out the details, see what happens, graph the thing, find the optimal. Okay? That starts to make a lot of sense. And you can do that with quadratic functions. You can always graph the quadratic function. You can always figure out the vertex of the quadratic function. And you might not even need to graph it. You know how to find the vertex. You're getting pretty good at that. Okay? Make sense? Okay. It's good stuff.